Now is it okay?
Yes, sir.
So this f is there. This is 45 degrees. Now this can be resolved into two components. What are they? F cos 45 and f sin 45 degrees. So the horizontal component is given as how many Newton? 50 Newton. That implies f divided by root 2 is equal to 50. Then what will be the value of f? So force is going to be 50 root 2 Newton, right? So if it is 50 root 2 Newton, what will be the vertical component? The vertical component will be f sine 45 degrees. Right? What is the value of f sine 45? F is equal to 50 root 2 into what is the value of sine 45? That will be 1 by root 2. This and this will get cancelled. Answer will be 50 Newton. So here what is happening is the horizontal component is also 50 Newton. Vertical component is also 50 Newton. The magnitude of the force is 50 root 2 Newton. Is it clear? Are you all able to hear me?
Yes, sir.
Yes, sir.
So is it clear?
Yes, sir.
Okay. Moving on to the next one. So man rows a boat with a speed of 18 km per hour in the northwest direction. Right? Northwest means what? Exactly
45 degrees.
so northwest, right?
That side.
So northwest means it is going to be 45 degrees. North, east. The short line makes an angle of 15 degrees south of west, meaning when it's an angle of 15 degrees. The shoreline makes an angle 15 degrees south of west. Obtain the component of the velocity of the boat along the shoreline and perpendicular to the shoreline. So this is a velocity 8 meter. Right? Is it clear? Now see, they're asking is mark this question as important. So they're asking us to obtain the component of the velocity of the boat along the shoreline and perpendicular to the shoreline. Meaning of it is this v vector is resolved into two components. What are the two components into which it is resolved? So when I say component, they are perpendicular to each other. What are the two components it is resolved into? One is this v is there, no? So the component of this velocity along the shoreline will be v cos of how much angle?
60.
It will be v cos of 60. Did you understand why cos 60 came? Because 45 plus 15, v cos 60. And here it will be v, the orange color line will be v
Sin
sin 60. Right? So velocity component along the shoreline is what? 18 cos 60. That is 18 into cos 60 is half. This and this will get cancelled. Answer will be 9. So 9 km per hour is the velocity along the shoreline. And what will be the velocity perpendicular to the shoreline? That is 18 sine 60. That will be 18 root 3 by 2, and this will get cancelled. 9 root 3 kilometer. Is that clear? So, what concept we actually applied here is we took this as x-axis, this as y-axis. Means we have rotated the axis. This is what is called as rotation of axis. Means if you want to find the component of a particular vector, you can find it along any vectors if you know the angle between those two. Is that clear?
Yes, sir.
Yeah. So 9 root 3 kilometer per hour. 9 root 3 should be around 15.6. Right? Shall I move on to the next one?
Yes, sir.
No, this one. So there are two billiard balls that are rolling on a flat table. One has a velocity component Vx 1 meter per second and Vy 1 minute. So can I write like this? Velocity of ball 1 is Vx I cap plus Vy j cap. Can I write it like this? So velocity of one vector is equal to I cap plus root 3 j cap. And other ball has a component of 2 meter per second and 2 meter per second. If both the balls start moving from the same point, what is the angle between their paths? So how to solve this step? So V2 vector is equal to, V2 vector is how much? Two I cap plus 2 j cap meter per second. Any doubt till here?
No, sir.
Okay. Let's see. So I'm going to diagrammatically show you. Observe. Let's analyze this question. I'll tell you two methods in which this can be solved. Now see, if I ask you to draw the velocity vector for 1, then how will you draw it? So what are the coordinates of the point? They both are moving in two-dimensional plane, right? So what are the coordinates of the points of the first vector? It is 1 comma root 3, right? If I take this as velocity 1 vector, I cap plus root 3 j cap, then what is the angle made by this velocity vector with the x-axis? Tell me, what is the angle made by this vector with the x-axis? If I take this angle as theta, then what is tan theta equal to? Yesterday I told you, no, whenever you have a vector as ai cap plus bj cap, tan of the angle made by the vector with the horizontal is what?
Y by X.
So root
Root
3 by 1.
1.
So that is root 3. Then what is the value of theta? 60 degrees. So this is 60. Similarly, belonging how much angle? It is 2j cap. It is going to be somewhere over here. Then what is the angle made by the second vector? This is theta 1. Tan theta 2 will be equal to what? Tell me.
1.
What will be the value of theta 2?
45.
40. So this angle 5 degrees. So what is the angle between both the vectors?
15.
That's the answer. Is this clear? So this is one way. There is an alternate way to do this also. The alternate way to find the angle between the vectors is using dot product. If I have two vectors, A vector and B vector, then cos theta between the vectors is given as A vector dot B vector divided by magnitude of A vector into magnitude of B vector. So, can someone tell me what is the dot product of these two? Dot product means what you need to do. You just need to multiply the coefficients of I cap, coefficients of J cap and add them. So, what will be the answer? Numerator will be 2 plus 2 root 3 divided by, what is magnitude of A? I mean, magnitude of velocity 1 vector.
Two.
It is 2 into magnitude of velocity 2 vector.
Two root 2.
That's right. Okay. So what will you have? You will have root 3 plus 1 divided by 2. Okay, root 3 by 1 divided by 2 root 2. If you observe, cos of 15 degrees is equal to this value. You can open your math textbook and see that cos 15 degrees will be equal to this value. So how we would have got this cos 15 is because cos 15 can be written as cos 45 minus 30. So cos of A minus B is cos A, cos B plus
Plus sin A,
sin A, sin B, right? So cos 45 is 1 by root 2, sin 30, cos 30 is root 3 by 2, plus sin 45 is 1 by root 2, sin 30 is 1 by root 2. If you take LCM and solve, you will get root 3 plus 1 divided by 2 root 2. This is an alternate way. But okay, if you have still not practiced dot product, it is fine. You can go with the first method itself. But are you able to understand?
Yes, sir.
Okay.
I have a doubt. Could you again explain that cos theta formula you did for the alternate one? My Wi-Fi connection was bad.
No, cos theta. Which one? This cos 45 minus 30. Yeah?
No, the right of that, sir. Cos theta equal to A vector into
That is the
B
formula.
vector.
A vector dot B vector divided by magnitude of A vector into magnitude of B vector.
There's a formula, sir.
That's the formula. You can go and revisit the topic named dot product. Okay, I would have explained the concept called as dot product or scalar product. You can just revisit. If you have a doubt, you can approach.
Okay, sir.
So, what I heard, the same only. Just wanted to explain the alternate also. And moving on to the next one. Find the value of lambda in the unit vector 0.4 I cap plus 0.8 j cap plus lambda k cap. So since they have told this as a unit vector, what is the magnitude of A vector? It is 1 because it's a unit vector. So square root of 0.4 square plus 0.8 square plus lambda square is equal to 1. Right? So squaring on both the sides, 0.4 square plus 0.8 square plus lambda square is equal to same one. So 0.4 square is 0.16, 0.8 square is 0.64 plus square is 1. So 0.16 plus 0.64 is 0.8 plus lambda square is 1. Lambda square is equal to 1 minus 0.8. So lambda will be equal to, it can be plus or minus root of 0.2. The answer is given as root 0.2. It can either be plus or a minus. It doesn't make any difference. Is this clear?
Yes, sir.
Yes, sir.
I'm proceeding to the next question. See. 16th node out, 18th node out, 19th node out, 20th. Okay. So how much did I change this angle to 40 degrees? So child pulls a rope attached to a stone with a force of 60 Newton. The rope makes an angle of 40 degrees with respect to the ground. Calculate the effective value of pull tending to move the stone along the ground. Calculate the force tending to lift the stone. So means they're asking you the horizontal and the vertical components. So there is a stone like this. Okay. There is a rope tied like this, and the child is pulling the rope like this. So this has horizontal component and the vertical component. So what is the force with which the child is pulling? It is 60 Newton. So if I take, let's take this angle as 60 degrees. So if I take this angle as 60, then how much will you get here? This will be 60
Cos
cos,
60 degrees.
and this will be 60 sin 60. 60 into cos 60 is half, that will be 30. So horizontal component, that is the one which is responsible for pulling it along the ground, is 30 Newton. Along the vertical will be 60 into root 3 by 2, that will be 30 root 3. This is tending to lift the stone. Are you clear with both?
Yes, sir.
Yeah. So only thing I guess 40 would have been an issue.
Yes, sir.
Yeah. So this is 20th. I think we are done. So there is only one problem that is left out. Which one was that? Sixth.
Sixth question, sir.
Okay. So there is a bird that moves with a velocity of 20 meters per second in a direction making an angle of 60 degrees with the eastern line and 60 degrees with the vertical upward. Represent the velocity vector in the rectangular form. Okay. So let me draw it diagrammatically. Observe. So this is the eastern direction. So it is moving with a velocity of 20 meters per second in the making an angle of 60 degrees with the eastern direction. Making an angle of 60 degrees with the eastern direction. Right? How much is this velocity? It is 20 meters per second. Now this velocity can be resolved into two components. What are the two components? This will be V. V how much? V cos 60, and this will be V sin 60. So V is 20. 20 into cos 60 is half. That will be 10. V sin 60 will be how much? So that is 20 20 into root 3 by 2. This and this will get cancelled. Answer will be 10 root 3. Right? So root 2 is wrong here, but let me check. Now what are they saying? 60 degree with the vertical upward. See, actually, this problem, the direction was actually not there for you guys. Okay, you can leave this question. Don't worry about it because it is to explain. Unnecessary confusion will rise. Okay, so leave this. Don't worry. It is based on a concept called as direction cosine. Did they explain direction cosine in your school? Did you hear this word, direction cosine?
No, sir. I don't
No,
think
right?
so.
Okay. See, if at all they explain it in the school, bring it to me. I'll definitely explain. But there's not there for you, at least for 11th. You learn about this in your 12th standard mathematics. Okay, the same chapter will get repeated there, whatever you did now. So that time it will be clear. But now I don't want to explain this because you have to visualize certain things. It will get confused. Okay. So accepting this point, I be comfortable with resolving the vectors in two-dimensional plane. Is there any other doubt that you have? Any concept which you want me to explain from this chapter, which is not clear?
Sir,
Anything pertaining?
if possible, can you once again explain the derivation for acceleration? I mean,
Acceleration.
uniform, sir. Centripetal acceleration, sir.
Yeah. So you want me to go with the textbook method only, right? The one which I explained here.
Yes, sir.
Okay. See, did you go through that? Or did you go through the video once again?
Yes, sir.
Okay. Now let's see. So what are all the points I need to consider? Tell me. So I will have a radial vector, right? So
Yes,
this
sir.
will revolve and it will come and stop here. It will make some angle with respect to the center.
Yes, sir.
Points that we used. I told you about the velocity. So if this is taken as R1 vector and R2 vector, what is the relation between the magnitude of R1 vector is equal to magnitude of R2 vector is equal to how much? R.
Yes,
Let
sir.
this be equation number 1. So how are the velocities? Tell me. The velocities are always tangential to the circle.
Tangential to the radius.
No, tangential to the circular path. Perpendicular to the radius, tangential to the, see, you need to either use a word perpendicular to radius or tangential to the circular path.
Okay, sir.
Okay. So then this will be V1 vector and this will be V2 vector. I hope this is also clear. So
Yes,
if
sir.
I take this angle as theta, then what will happen is, see, if I join these two, then I can think of this point as O, P and Q. Then this is OP vector, this is OQ vector. Okay. Now what I'm going to do is I'll draw a separate diagram for OP vector. I'm replicating the same diagram that is there. Observe OP vector, OQ vector, and PQ vector. Till here, is it clear?
Yes, sir. Here, OP vector and OQ vector is R1 and R2, no, sir?
R1 vector and R2 vector, yes.
Yes,
R1
okay,
vector
sir.
and R2 vector, but their magnitude is the same. Why are they different in terms of vector quantity? This also explained. Because they have different directions, right? So if you take this angle as theta, then what is PQ vector equal to? PQ vector is equal to OQ vector minus OP vector. You remember this? So PQ vector is equal to OP vector minus OQ vector. See, if at all you don't remember this, not an issue at all. You just use the triangle of addition. OP vector plus PQ vector will be equal to OQ vector. So PQ vector is equal to OQ vector minus OP vector. What is OQ vector minus OP vector?
R2 vector minus R1 vector.
This can I write it as delta R vector, this R2 vector minus R1 vector.
Yes, sir.
So this will be delta R vector. Means that is a change in the radial path. Now this V1, observe what I'm going to do to V1 is, wait. This V2 vector, this V1 vector. So V2 vector and V1 vector. So this V1 vector, I'm bringing it down. Okay, I'm trying to draw a separate diagram again. This is what? V1,
V2.
No, this is V1 vector because R1 is there, no? V1
Yes,
vector.
sir.
Now this is there, I'm bringing and joining it here. Then what is this?
V2 vector.
Okay,
Yes, sir.
so I'm joining these two parts again. Wait, I'll join it in the reverse like this. Now, what will this point be? Say if I take this point is how much? OP, right? The tail of P, V1 is P. V2 vector. Okay, I'll label it as something else. I'll take it as ABC. Now tell me, if the angle between R1 vector and R2 vector is theta, what will be the angle between V1 vector and V2 vector? That is also theta.
Theta.
What is the reason for it? If the angle between two lines is theta, the angle between their perpendiculars will also be theta. So that's the reason you need to write. Now tell me what is the relation between AB vector, BC vector and AC vector. So AB vector plus BC vector is equal to AC vector. Accept it? So BC vector is equal to AC vector minus AB vector. What is AC vector? V2 vector minus V1 vector. So this delta V vector.
Yes, sir.
Because it's a change in velocity.
Sir.
Okay. So delta R vector you have got, delta V vector you have got. Now tell me what is the relation between OPQ and triangle ABC in terms of similarity?
They have the same angle, theta.
Okay. So which two triangles will be similar? Triangle OPQ is similar to triangle ABC. Because OP is related to R1, AB is related to V1.
To
That is
V1.
how okay. So it will be like this. Then OP divided by AB is equal to OQ divided by AC will be equal to PQ divided by BC.
Sir.
Right. So what is
Correct.
OP? OP is
R1 vector.
it is R1 vector. But what did we write? Since you taken only triangle into consideration, you will write its length. So OP is radius. What is AB? AB is velocity.
Velocity.
And one more point, for uniform circular motion, the magnitude of the velocity is the same.
Okay, sir.
Okay, so R divided by V will be equal to, what is OQ?
R by V.
R by V is equal to, what is PQ? Delta R divided by,
Del R by del V.
that's it. So any of the R by V, I will take it into consideration. So from this I can say del R by del V is equal to R divided by V. Now rearranging the equation, del R by R is equal to del V divided by V. Can I write it like this?
Yes,
So
sir.
dividing with T on both the sides, delta R by delta T into 1 divided by r is equal to delta v by delta t into 1 divided by v. So what is delta r by delta t? It is nothing but velocity
Sir.
into r. Velocity divided by r will be equal to what?
Acceleration into 1
By
by
v.
v.
So a will be equal to v square.
Okay, sir.
So that's the relation. That's why we say centripetal acceleration is equal to v square divided by r. So did they teach the same method?
Yes, sir. They explained the similarity of.
Similarity only, because there is another derivation also, which is done using the process of differentiation. So if they have taught that, I thought of explaining it. Surya Seshatri.
Sir, I have a doubt.
Surya, yes. Rohan,
The
just-
force is acting towards the center only, no, sir?
Yeah, force is acting.
It will always be acting towards
Force is
center.
acting. Yes. That's why it is called a centripetal acceleration.
Okay, sir.
Meaning this is from the word inter. So if there is any acceleration which is seeking towards the center of the circle, that is what is called as centripetal.
Centripetal acceleration. Okay,
Yes.
sir.
So if you multiply that centripetal acceleration with mass, it becomes centripetal force. That we will see from next chapter onwards.
Okay, sir.
Okay. So in this chapter, any other doubt? Surya, are you there? Okay. Surya, can you tell me how did they teach you this one? This derivation? The centripetal acceleration. The one which I derived now. Okay, then it's fine. Any other doubt, guys? Any other doubt from this chapter?
Sir, for us, he used differentiation only.
For you, they use differentiation. Who's that actually? Who spoke now?
Sir, it's Siddesh.
Siddesh. Do one thing, can you send me the screenshot of the derivation which was taught? After the class, you can send it to me. I will have a look and I'll explain it. Because if they're taught in that method, then I will teach in that way. But this is the book method. That is why I had to go with this. This is the NCERT method. Some teachers explain this. Some explain using the process of differentiation.
Okay.
Okay. You send it to me. I'll have a look at it. Any other doubt? Any other doubt other than this? So if no more doubts, we can wind up.